Welcome to part 2 indices. So in this one we'll look at worked examples on how we can use those indices rules that we looked at in the first part of indices. So we'll use those rules. I'll be pointing out on how we apply each and every rule to solve this. So we have 5 questions that we're going to solve, and hope you guys find this tutorial video useful. So if you find it useful, please at the end of this tutorial video, remember to like the channel, that is TA Thinking Aid. Leave a comment so that we know where to improve or de-improve, and the most important, subscribe to the channel so that you get new updates on our new videos. I'm Lewis M. So let's start. Okay, so the first question is negative 2x to power 0. So that's our first question. So let's solve it. So our first question says solve the following. So it's negative 2x to power 0. So in this case, what is important for us is to realize that one, any number, according to the first rule, any number, let's say a raised to power 0 is equal to 1. So in this case we have x. This x is raised to the power 0. So we're going to have negative 2 multiplied by, we know that x to power 0 is equal to 1. So write 1 here. This one is 4. We know that x to power 0 is equal to 1. So what do we end up having? We have negative 2. So negative 2 times 1 is negative 2. So it's simple as that. It ends here. This is how simple this one was. Now the second question states that 3 to power 2 plus 9 to power 3. So we have to work out this one. So this one was our question 1, and we're going to go to question 2. So question 2 says 3 to power 2 plus 9 to power 3. Now for us to solve this equation, it's very important that if possible, you guys, if you have look at the base, is it possible for you to reduce the base into indices form? Let's say for instance we have 2 bases here. The first base is 3 and the other base is 9. So can we write 9 in form of a base so that we have a common base? So that one becomes very important. So let's say for instance we know that we can write 9 in form of a common base. What are the small numbers from 2 up to 9 that can go into 9 without leaving a remainder? You guys too can't, you realize that we have 3. 3 into 9 goes how many times? Goes 3 times. Can the same 3 go into 9? Yes. How many into 3? Yes. How many times? 1. So you realize that 9 is same as 3 to power 2. Okay, so now we can write this expression. So just a point of correction, allow me to change this plus into multiplication. There was a mistake here guys. Okay, so what do we end up having? We have 3 to power 2 multiplied by, now in this case we are not going to write 9. We know that 9 is the same as 3 to power 2. So we're going to write 9 in form of 3 to power 2. So we're going to say 3 to power 2. Then we have the power which was already on 9, which is 3. So see how we have simplified this. It becomes easy. So what do we do? According to the which rule was that? According to, let me see if I can remember the rules. Which rule can we use? So according to this 5th rule, if you watch the first part of indices, we have 3 to power 2 multiplied by, now here we have 3 to power 2, then in brackets to power 3. So here these 2 powers, according to the 5th rule of indices, they are multiplying. So we're going to have 3, then 2 times 3, which is 6. Okay, so we have this one, and then we have, now according to the 3rd rule of indices, when you are multiplying an index expression with the same base, you simply add the powers. So that was the point of us changing 9 into this form. We wanted to have a common base, which is 3. So what do? You simply copy the base and then you add the powers. So that would be 2 plus 6. Remember, we are using this row of indices saying if you have a to power m times a to power n, you simply say a then m plus n. So that's the rule you guys we are using here. So we have 2 here, so 2 to 2. Okay, so when you add this, we're going to have 3 to power 8, and that's your answer. See how simple this you guys is. So that was our question 2. Okay, we go to the next question. So the next question is question, what's our next question? Let's see how our next question is. So our next question, so I need a bit of enough working paper. Okay, we'll use this one. So the next question says work out the following, which is so we have this question here, which is our question 3. Question 3 is written as 2 over r to power 2 negative 3. So what should you note first? The first thing to note here is we have a negative power. So according to the rule of indices, what happens when you have a negative power, meaning the whole expression becomes, so which rule are we looking at? We are looking at this rule. When you have a to negative n, this simply becomes 1 over a to power n. So we have to rewrite this whole expression in form of this expression. Okay, so we come here, so we are going to have 1 over 2 over r to power 2 then to power 3. That's your first step. Now once you do this, we go to the fifth rule of indices. So remember that this 3 which is outside the bracket, which happens to be the power, is the power for both the 2 and r to power 2. So this will become 1 over, now this will become 2 to power 3 over r, then 2 times 3, something like this. I hope you guys are following. Then from there, this goes like this. Okay, so we have 1 over 2 to power 3 over, what is 2 times 3? That's r to power 6. So r to power 6. Okay, so our r to power 6 is equal to, now we have to simplify this. We know that we can rewrite this as 1 divided by 2 to power 3 over r to power 6. Okay, so now we have to simplify this expression. So this expression can be simplified as, so we come to this one. You can say 1, n number, if you want to make it a fraction, you just put 1, then multiply by, so when you are changing the sign of a fraction sign from division to multiplication, you swap the numerator and the denominator, so it becomes r to power 6 over 2 to power 3. So when you multiply this, finally, this is what we are going to know. You know that 2 to power 3 is 8. So this one will become like this, and your question ends here. So this is how simple this question could be solved. Then our fourth question. So our fourth question is let me see if I can squeeze my fourth question in this space here. So to differentiate it, I'll use Pro Ink to solve my fourth question. Okay, so my fourth question, question 4, is, okay, so 5 times 8 to power 2 over 3. So here I'll maintain my 5 because it's not changing, times. Now remember when you're dealing with fraction powers, we said when dealing with fraction powers, you have to determine, is it a square root, a cube root, or a fourth root? So what will help you determine is you look at the new denominator for the power. So if the denominator for the power is 3, you know that's it's a cube root. If it's 2, you know that it is a square root. If it's 4, it's so in this case our denominator for the power is 2 over 3. So denominator is 3, which means it's a cube. So this whole expression, this one, can be written as, you have this sign because it's a fraction power, and then you have your base here, which is 8, and then you have, now here what we put is n, and our n in this case is the denominator, which is 3, and what you put outside the bracket is m. Our m is 2. So something like this, so that now in this second stage it becomes multiplied by, we have 8 here, then here you have 3, and then outside you have 2. So we know what is, you know that this expression in the brackets means what is the cube root of 8? What number can you multiply itself 8 times? It gives you 3 times, it gives you 8. You guys, we have been doing this, and you know now that it is 2. So we have 5 multiplied by, so the cube root of 8 is 2. So we have 2 to power 2. So what do you get? You guys, have 5 times, what is 2 to power 2? That is 4. Then finally 5 times 4 gives you 20. Sharp, you have simplified it, simple as this. So this is how you would solve the fourth question. Let's look at the last question. The last question, which was question number 5. Now question 5 was asking us to find the value of x. So we are given an explanation, an expression where we are required to find the value of x. Okay, so let me cover the whole thing. So saying find the value of x when you are given this expression. So our expression is, so this was our question 5. So our expression is 3 times 5 to power x is same as 125. Now they are telling you find the value of x. That will make this which is on the left hand side be equal to this which is on the right hand side. You guys, it's simple. Like I said, using indices you're able to manipulate anything you guys can come across. Okay, so let's see. What do you do here? So on one side we don't have a fraction, the other side we have a fraction. So in the next step you make both as a fraction. So you say 3 times 5 to power x is equal to 1 over 125. So you make this as a fraction. When you make that as a fraction, you guys, you can cross multiply. Okay, so you can do your cross multiplication. When you do your cross multiplication, this is what we are going to come up with. So what we are going to come up with is something like 3 times 5 to power x times 125 is equal to 3. Okay, so you have an expression. When you cross multiply, this is what we're going to have. When you have this, you can divide throughout, because this is what I realized. I realized that on my right hand side I have 3, and on my left hand side I have 3. So I can divide the whole expression on both sides by 3. So when I divide by 3, I know that 3 here 1, 3 here 1. So this 3 here 1, this 3 here. What do I remain? The expression that I remain with is 5 to power x times 125 is equal to 1. Okay, now I want to make 5 to power x the subject of the formula here. So what do I do to make this subject of the formula, this one to remain alone as subject of the formula? I need to divide on both sides by 125, and on both sides 125. Okay, So what do? I realize that 125 goes and I remain within, and 5x is equal to 1 over 120 to 125. Okay, so now what do I do when I reach here? When I reach here, it's simple. I have to express 125 in index form. So here I have to make this 125 in form of an index form. So how do we make 125 in form of an index form? I have to look for a number from 2 up to 9 that can go into 125. So can 3 go into 125? No. 4? No. 5? Yes, it can. So let me try with 5. So how many times does 5 go into 125? It goes 25 times. Can the same 5 still go into 25? Yes. How many times? It goes 5 times. Okay. Can the same 5 go into 5? Yes. How many times? 1. So I realize that 125 in indices form is same as 5 to power 3. Okay, so this is what I'm going to have here. So I'll come back to my question and I'll say 5x is same as 1 over, now I'll no longer write 125, I'll write it in indices form, which is 5 to power 3. Once I've written like this, now if you go to this rule of indices, okay, so you have this rule of indices. It says a to power negative any number is same as 1 over a to power n. And this is what I realize. I realize that if you look at my expression here, 1 over 5 is almost something like this. So I know that here the rule which I'm employing is this rule. So what do I remember? Or what I know is that for me to now convert this into this, I know that this negative here is representing 1. And then this n is the same n, and then this a is the same a. So similarly here, if I were to come here, I would do something like this, okay? So I would say, since I know that the base is the same, 5 and 5, so I will know that my x I'm comparing have the same base, So meaning even x is the same one, because if you remember here, the same n is the same n which came here. So I know that my x is equal to 3. But is it 3? No, it's not complete, because this is what I realize. I realize that for me to have 1 over such an expression, meaning my power needs to be a negative. And then I know that now I am correct. So if you guys you are to put negative 3 on this one, if you want to prove, let's say you are done, you just want to prove, you would say 3 times 5 to power negative 3. What do you get, you guys? You are going to get 3 times, what is 5 to power negative 3? It's 1 over 5 to power 3. So this one will be equal to, what is 3 times 1? It is 1 over, what is 5 to power 3? That's 125, which is same as, so this one is same as this in our original expression. So here you can, you know that we're going to get 3. So this is how you can apply indices. Hope you guys you have liked this worked examples on indices. Please, if you have, remember to write to the channel, leave a comment, and please, most importantly, subscribe to the channel so that you can get new updates. I'm Lewis M on TA Thinking. Keep supporting the channel. It's a Zambian channel. Thank you.